This is the guided note video for graphing linear inequalities. The learning target is I can graph a linear inequality in any form. We graph linear inequalities the same way we graph linear equations. The only difference is we will have to show that our line represents a variety of solutions, not just the points on the line. To do this, we need to think back to dotted versus solid and satisfying an inequality. So at this point, we now know how to graph a line that is in slope-intercept, standard, and point-slope forms. Okay? This will not change when we're graphing linear inequalities, only our sign changes. So to graph a linear inequality, we need to show that this line will represent several ordered pairs, not just the ordered pairs on the line. Okay, to do this, we will have to determine if our inequality has a dotted or a solid line, and then pick a test point to plug in to our inequality. Okay, give you a second to write that down. If the test point makes the inequality true, we will shade the side of the line that the test point is on. If the test point makes the inequality false, we will shade the side of the line that our test point is not on. Okay, so if we have a test point that's on one side of the line and we plug it in and it's true, we're going to shade the side of the line that the test point is on. But if that inequality becomes false, we're going to go ahead and shade the opposite side of the line. Okay? Okay, so last thing, just be sure to plug your test point into the original given inequality, okay, because we will see that we may have to switch signs here depending on the type of problem. So if we plug it into the original inequality, regardless if we had to switch the sign or not, we won't get confused. So let's take a look at an example in slope-intercept form. Okay, so we have y is less than negative 1 over 5x plus 4. Okay, so first off, I'll determine if my line is dotted or solid, and my sign is less than, so I know it is dotted. Okay, I don't need to manipulate it in any way because it is in slope-intercept form, so I'll start at positive 4 and make a point. My slope is negative 1/5, so I know my line will be sloping down from left to right, so I'll go down 1 and to the right 5. Down 1 to the right 5. Or I could go up 1 and to the left 5. Okay, and I know it's a dotted line, so I'll make a solid line all the way across. And then dot it appropriately, okay? Okay, so there we have our line. Okay, now I need to plug in a test point. So for my test point, usually I'm going to plug in 0, 0. just because that's typically going to make everything go away. Okay, it's easy arithmetic, even if we have fractions. So I'm going to plug in 0, 0. So I get 0 is less than negative 1 over 5 times 0 plus 4. So I'll keep evaluating. I have 0 is less than negative 1/5 times 0 is 0. And then I've got plus 4. And then my last step, 0 plus 4 is going to be 4. So we have 0 is less than 4. Okay? That works out. That's true. So looking up in the paragraph above, okay, when I plug in a test point and it makes the inequality true, such as 0, 0 just did, I will shade the side of the line that the test point is on. So since my test point is on this side of the line, I will shade this side. Okay, and I'm not asking you to color in every single box, just make it clear which side is shaded and which side is not shaded. Right, pause if you need more time. Okay, so here we have an example in standard form. So first thing I'll do is determine if it is dotted or solid. So we have 4x minus 3y is greater than or equal to 15. Because I have that equal to sign under my greater than, I know this is a solid line. It is included. And now what I'll do is I'll manipulate this equation to get the y by itself so it is in slope-intercept form. So first step, I'll subtract 4x from both sides. When I do that, 4x minus 4x cancels. So we get negative 3y is greater than or equal to negative 4x plus 15. Remember, we can't combine these because this negative 4 has an x attached to it and the 15 does not. So our last step, we'll divide by negative 3. We're dividing everything by negative 3. When we do that, negative 3's on the left side cancel. So we get y. We divided by a negative, so our sign is going to flip to less than or equal to. We have negative 4 divided by negative 3, which is 4 over 3. And we have 15 divided by negative 3, which is negative 5. So we now have y is less than or equal to 4/3 x minus 5. So I'll start at negative 5. And my rise is 4, so I'll go up 4 and to the right 3. Up 4 to the right 3. And then I can go down 4 and to the left 3. So I'll make my solid line. Okay, and now I need to plug in a test point. So for my test point, I'm going to plug in 0, 0 again. Okay, so 0, 0 is on this side of the line. Okay, and I'm going to plug it into my original given inequality, okay, the one that's actually still in standard form. Because I had to flip the sign down here, some people might forget to flip the sign, so by using my original given inequality, there's no confusion over sign flipping. Okay, so when I plug that in, I get 4 times 0 minus 3 times 0 is greater than or equal to 15. So when I simplify this, 4 times 0 is 0. Negative 3 times 0 is 0. And then I have the rest of my inequality. So last step, 0 minus 0 is 0. So I get 0 is greater than or equal to 15. Well, this is not true. 0 is not greater than or equal to 15. This is false. Okay, and because this is false, I'll go to my test point, and since it's on this side of the line, and this is the side of the line where my solutions or my ordered pairs do not satisfy the inequality, I'll hop over to the other side of the line and shade this side. Just like that. Can't forget my arrows. Okay, I'll move on to the last example. Okay, so our last one, as I'm sure you could have guessed, is a linear inequality in point slope form. So we have y minus 7 is greater than negative 3 times x plus 1. So first off, dotted or solid, it's going to be dotted because my sign is greater than. Now what I'm going to do, I'm just going to distribute my negative 3 to everything in parentheses, get the y by itself, and then I'll have an inequality in slope-intercept form. So when I do this, I get y minus 7 is greater than negative 3x minus 3. So I'll add 7 to both sides. When I do that, negative 7 plus 7 cancels. So I get y is greater than negative 3x, and negative 3 plus 7 is going to be a positive 4. Okay, it is in point slope or slope intercept form now. Went from point slope to slope intercept, so I'll start at plus 4. And from there I'll go down 3 to the right 1. Down 3 to the right 1. Or I could go up 3 and to the left 1. Up 3 to the left 1. And there should be no confusion over whether I'm going left, right, up, or down, because my slope is negative. It was negative 3. So that means my line is going down from left to right. And last step, let me make it dotted. Okay, so now I need to figure out where I'm shading. So I will shade, or I'll pick 0, 0 as my test point. So when I do that, I'll plug it into my original given inequality. So I have 0 minus 7 is greater than negative 3 times 0 plus 1. So 0 plus 1 is going to be 1. So we have 0 minus 7, which is negative 7, is greater than negative 3 times 1. Negative 3 times 1 is going to be negative 3. Sign's not changing at all because we're not multiplying or dividing by negative. So we get negative 7 is greater than negative 3. This is false. Okay, so we go to our test point, which is on 0, 0, which kind of looks like to the left of our line. Okay, because it's false, we're going to hop to the other side of the line and shade that portion. This is the side of the line where all our ordered pairs will satisfy the inequality. Okay. At this time, I would move on to the example video for graphing linear inequalities.